Great, welcome and good morning, everybody. It's very exciting to be one more year here. It's always, like as Flo was saying, this is a very special location for us. This is where the Spatial Data Science Conference started. It's always great to see you all around. I cannot wait for the presentations and the meetings that we're all gonna be having in the coffee shops, in the coffee and so on. But today I'm going to be talking about two of the most hot topics, I think, in our industry that I think we're probably going to be saying 1,000 times today around AI, generative AI, and H3. Something reminds me, I think we're going to have a lot of conversations around this. And that is actually, I think we are in a very interesting moment right now where we see a lot of organizations now starting to move towards this paradigm. So I think it's a great moment to talk about this in particular. But before that, again, I like to start, with, always some great maps from here, from the city, and, from looking from Colombia. This year, if you haven't seen, this contour maps map of lines, I think it's great. And it's actually going to give me a very good head towards, also talking about flooding and water. But I think it's a beautiful map of the city, and as always, I think, there's no better place, I think, in the earth to make maps than in New York, right? So before that, I also like to start thanking our sponsors. So they make this conference possible, and also they add a lot of value to the conference, by the workshops that they made yesterday, but also on the booths. I really recommend that you go and visit them. It's a great way to know what it's up to in the latest when it comes to technology, but also to in terms of data providers. I think it really makes a big part of the conference. So, and thank you very much for them for sponsoring. Now, also yesterday I was. How many of you were yesterday in the workshops? So you can just raise your hands. That's a lot of you. I think they were great. I think the location was amazing. The content was great. And I think it's one of my favorite parts, is where we really can dedicate time to spend, on doing things and learning, and also really talking to each other. So if you haven't, I highly recommend it. I think they were really great content. I want to thank everybody that contributed, participated, but also give them. Now, as usual, I kind of like to start to start talking with what I think is one of the obvious most pressing issues of our society, right, which is climate change. I think this year in particular, it's even more. We've all seen it. I was talking in the last Spatial Data Science Conference in London before summer, and we were already kind of expecting a very big, very kind of hot summer. Well, it's clear. We are on a clear path to have the warmest year of history. And it just doesn't seem to kind of be getting better. Well, we know it's just only going to get likely worse. And in that sense, geography is going to be a very important part, as you will see, of what I believe, we'll have a very strong responsibility, to work on it. Again, this summer we've seen, a record number of heat waves, and around the world. And in Europe it was massive, but so it was here in North America, all around the world, massive floodings, and also massive fires all around, right? And this is something that now is happening more frequent than ever, and that we're having to adapt faster probably than I think most of us were even, or most people were even thinking about. Particularly here in New York, flooding is one of the biggest issues. I know it's actually quite a controversial topic. We know if you look at, the city is quite vulnerable to flooding with all this very large coast that it has. And we've seen, during this summer, the effects of that, right? So for me, actually, it's reminding us something as our industry, that I'm reflecting more and more, which is the fact that we've been an industry that is being focused on planning, in a way, trying to figure out what is happening, prepare for the future. But now, we're coming to a time where we need to act much more in real time. We need to apply our skills of analytics of things that are happening right now, not, not in something that is going to happen in the future. So we need to move to a more, dynamic and real-time analysis. When these heat waves are coming, and they're coming more often, or this flooding, they're coming at times that, we have to be able to do predictions, or, to drive decisions faster than ever. So I think, in that sense, our industry is moving towards a much more dynamic and real-time analytics in a way. And I think, like, we have to be prepared for that. It's part of our responsibility when it comes to prepare, for mitigation, what is coming, right? And an example of that, I saw it again back on the concept of here in the city of New York. So like I said, New York has 520 miles of waterfront, so it's very vulnerable to flooding. And I want to show you an analysis that we did, or an experiment, to showcase what I mean by this type of dynamic and real-time analysis. So when a flooding comes, when a flood comes, what are the infrastructures that are going to be affected by these floods, right? What are the consequences? Which infrastructure is going to get affected? Like how is that actually going to disconnect population? Things like this that we're going to now to be able to answer in a much faster way than we used to. So, so for that, actually, I want to show you an example of how we did that. So following, like this concept, I mean, we designed a workflow, a CARTO workflow that allows you to essentially connect the alerts. You will see in the minute, the alerts and like the information, from the weather services, and and predict, like which populations and so on are going to get affected on infrastructure. So let me run down you a little bit about, how this looks like. So it all starts with defining the area of interest, right? So you define, like the area that you want to monitor, right? That you're going to be focusing on, and that you're going to be doing your analysis, right? So in this case, just using New York City. Then if you know where, I mean, like the National Weather Service has like a great API for alerts. So you actually, at any time, and it refreshes like in real time. So you have like, it's an API that is always updating. So every 5 minutes you have new alerts. And you can get there, the GeoJSONs in this case, like the locations where there's alerts with, what is the severe of, those alerts, the type of alert. And in the case of a rainfall, how much rain is expected, like in these areas, right? So what you do with that is that you can intersect it with a flooding model. And in this case, we work with Fathom, which is one of our partners when it comes to data. They have a global flooding model, and particularly here in North America, that allow us to see, like, okay, if there's this much rain, what is the risk of different areas, to get flooded, and up to what level, right? And there's these different scenarios. So if you intersect these alerts and with how much these alerts with this flood model, you can get already, like the areas that are going to be likely be in the water that are going to be affected. Now, the next step is, I think, is pretty cool because we're using in this case Gen AI to actually looking at, okay, this is the areas that we know are going to get flooded, and this is the alert that the National Weather Service is giving us. Which infrastructures are going to be affected by that? And in order to do that, if you look at the alerts that the Weather Service gives you, it's like it's a raw text that that essentially we pass here to the Gen AI in the prompt to say parse it and tell me what type of infrastructure will be affected by this alert, and respond me in a way of OSM OpenStreetMap tags so that I can go and query OpenStreetMap to get that infrastructure. So you see, so in this case, it's the Gen AI who is parsing the alert and is creating the query or the tags that then I can use on BigQuery to actually go and retrieve the data from the OpenStreetMap database that you have on BigQuery, right? I think it's a pretty cool use case of Gen AI. Well, now that we have that, we have the potentially affected infrastructure, right, that is going to come. So we know now that. And with that, you can go and analyze things like, okay, what is the amount of, what is the population that is going to get affected? Which of these populations are going to get, like disconnected because of, the roads are getting flooded or the trains are not going to serve, et cetera, and so on. And then you can run an alert, right? So this type of, like going from all the way from the intersection to the analysis of who is going to get affected and, and getting a notification system with a report on real time is what I'm thinking, like we don't do an analysis of what it will happen under different scenarios. We will still do that, but we're also going to have to design analysis that, when these events happen, we actually can have a report immediately that is prepared, to know what's going to be the situation. Now, this is, in a way, what I call like trigger-based analysis. It's, in a way, this analysis is being triggered by the Weather Service, setting up an alert, right? and then having access to all those different data sources, update it on their own to get the most up-to-date result of this analysis, right? And this is a pretty incredible kind of infrastructure if you think about it. I mean, we have so many data sources updating on their own, and we just kind of using them to do our own specific analysis. This is, from my point of view, it's an incredible marvel that we have now. Now, the way that we're thinking about this also is to operationalize it even more. Think about this entire analysis that you can store it as a stored procedure on your data warehouse or your database. And this is a new functionality that is coming with CARTO workflows. The possibility to take that analysis and say, now I want to export it, I want to save it as a stored procedure, and now it's going to be part of my, my system. So every time something happens, this whole analysis will just run on its own. So, so for us, that's a very important part. And also you can call it, through APIs. So it's a lot of integrations with that. So for me, it's a pretty exciting way of thinking about how to move to something that is much more of operationalized, that it's always going to be there, prepared to be run whenever it's needed. So this trigger-based, in a way, kind of analytics, right? So going back to this from dynamic real-time analysis. I want to show you another example. Another thing that we care a lot, well, I do personally care a lot about, it's on the concept of on the area of biodiversity, and it affects a lot climate change, is deforestation. So between 1999 and 2020, an area similar to Europe, which is more or less the same area as the United States, was deforested. So that's actually a lot. And this year, the European Union has passed a new regulation to ensure that no products are sold that come from places that have been deforested, right? And now companies have the obligation to actually check if the sources of the goods come from places that have been deforested after 2020. It's part of their due diligence that they have to present, right? So it's their responsibility. So it means that they need to look at where are the farms, where are the places where they're sourcing the goods, and analyzing deforestation on their areas. Right? So pretty important one. So that's another typical analysis that we can do in these cases. Whenever they're going to be transacted with a new provider, well, you're going to need to know where their farms are, their vectors in a way, like in here at the bottom, and you're going to have rasters, for example, of deforestation, right? What is the deforestation and degradation? The actual mandate enforces both. So you're going to need to intersect these two and see and get a report. It's been deforestation going on, since 2020 in the area, in a buffer around, inside the farms, but also in a buffer around a kilometer, et cetera, et cetera. And you're going to see more and more information systems like this that need to be put actually at the procurement systems within those companies, right? Because they're going to need, before they click on buy-in or getting an agreement, they're going to need to check these things, because they're going to need to make a a compliance report, and to ensure that they're sourcing from there. So this is an example of these raster and vector intersections that we're looking also at CARTO in a particular farm, right? And it is actually a lot of deforestation, as we've talked about, right? So as you as you zoom in here, I mean, the pink areas are places that have got deforestation or degradation just from 2020. So it's going to be a pretty precise type of analysis you're going to have to do when doing sourcing. Now, California has also a similar legislation going on. It's called the California Deforestation Free Procurement Act. And actually, right now it's being debated here in New York, also a similar legislation that they're trying to pass. So I certainly invite you to support it, because I think it's one of the most important mechanisms that we can have, to protect forests, tropical forests. Great. So now, all this type of analysis, from my point of view, require of these three things in a way that we have now available. So the first one is the data cloud, right? So this availability you will see around, how do we have access to all this data that is updated by the data providers, and that we have, always, this uniform place to do analysis as a single source. That's the data cloud. H3 indexes, because if you're going to be uniting many sources, you're going to need to have some common geographic support system to do your analysis, as you all know. So H3 indexes are really becoming very popular for that. And I like also to talk about how Gen AI can help a lot also in this type of analysis. I'll show you a little bit on that. So there's three things. Let's start with the first one, with the data cloud. Now we have a slide for that. So yeah, well, a lot of data cloud engines or products, I mean, are already supporting geo. That's the good news. So you probably are using one of, I mean, there's many other products, but like some of those products, and they all have like geospatial support, which is great. We can do now. And if you look about, like 3 years ago, that was not the case. Geo was not possible to be done in the data cloud. Now it's possible to do geo on the data cloud because they have support for geo, which is amazing. Now, we could do more, and one thing that we've been pushing now for a couple of years is being something called GeoParquet, which is adding geospatial support on the Parquet format. It's a very popular data format for big data and the data cloud-like systems. And GeoParquet really is going to help us not only to be interoperable, like you see, I mean, like if you have a data set on, let's say, on BigQuery and you export it in Databricks, you're not going to be able to have like geo on it or to a Snowflake. There's interoperability issues between the data clouds. GeoParquet will help on that. But it's also very good, when it comes to performance. So it is a cloud-native data format, which means that, like you only use or you have to download only the parts that you need. It's very effective on the way that it partitions the data. And it's also very cost-effective. It compresses really well, and you can use it, on cloud storages and so on. So it's going to be a very important part as we move forward. Now, one thing that I really like about it is, like I said, like the first step that we're like going for is interoperability. Imagine that you can export a table from BigQuery and import it on a Snowflake, and the geospatial column remains a geospatial column. That's not the case now. It will with GeoParquet. So that's kind of like interoperability at the high level. But then the next step is when you really kind of like we are enabling a distributed system where you store your data and you consume data from data providers that is stored at GeoParquet files on the cloud storage, and you can use it from whichever data engine. You can use as many as you want, as many as you need, and depending on what you're like doing, but you're only storing it once in one single place, and all those engines are just leveraging that. So that will be a pretty big, win for our industry. It's still not there yet. I mean, there's a number of things have to happen. First of all, in the form of support on these data warehouses for GeoParquet, but also around spatial partitioning and so on. There was a talk yesterday at the workshops that was really interesting around GeoParquet. Now, the great news is that 1.0 has been released. 2 weeks ago, we finally released GeoParquet, and this has been a huge effort by a lot of organizations, and that has actually really mean that now we are ready to kind of like implement it. So we hope this will accelerate a lot adoption in the major products. We've seen already incredible momentum. There's already 12 tools, but it's just kind of like going up faster and faster, that supports GeoParquet. There's 8 libraries or languages. There's libraries now pretty much for every language you can think of. And there's like tens of data sets already published in GeoParquet. So if you are like a data provider, you might consider start publishing your data also in GeoParquet. I mean, and the ecosystem is just growing a lot. So I'm very, very happy with that. Oh, another thing I forgot. Oh, no, I think it comes later, sorry. But this is another announcement. We want to accelerate adoption. So actually, Planet and CARTO, we've partnered together with OGC, with the Open Geospatial Consortium, to do a call for proposals to get organizations to propose new libraries or tools or even data sets that can actually add GeoParquet support. So if you're working on any open source project or open data project that you think could benefit from GeoParquet, there's a call for proposals starting this week that you can apply to, and actually we'll be funding some of it. So I think we hope it will accelerate more the adoption. That's one side. So that's on the data cloud, on the news on the data cloud. The second one is around H3 indexes, which I think, I like to say is like a single geographic support system to all. Kind of like in a Lord of the Ring type of things, right? But like type of message. But it really is. I mean, like H3 is becoming a de facto standard for doing a lot of analysis. We've seen tremendous growth on it. We've seen it, like on things like we have a 101 spatial indexes on our website, and it's like download a ton. So people like it a lot. There's a lot of people learning about how to like now operate with H3 and spatial indexes. And yeah, I invite you to look at it. Also, one of our most popular blog posts and content actually is the top 10 use cases and demos of using H3 that we have on our website. I mean, some of them are pretty cool. I mean, like in terms of like analysis around dividing population in countries. Like it's a ton of stuff. But there's one in particular I wanted to highlight because I had to highlight that I saw yesterday. There was Helen McKenzie actually did a map analyzing the Swift effect, Taylor Swift effect, and I really like. So it's essentially kind of like to look at areas that have like very large number of Taylor Swift fans, and that could actually make use of the Swift effect in the sense of, like, will benefit, from having concerts to boost their economy. So, I mean, this is one example. We're also adding more and more advanced capabilities on H3 on products like CARTO. So, for example, there's this new GEDIS or QuadBeam. It's a way to analyze spatiotemporal data sets to look for not only a spatial cluster, but spatial temporal clusters. So there's a great blog post around analyzing, I think, traffic bike accidents, and where you're not looking at the places where there's more bike accidents, but the places at the times where there's bike accidents. So you see, we're starting to see much more also support of the temporal analysis together with H3, which I think is going to be really, really cool too. Now, it is already supported H3 in most of the data warehouses, so a lot of them actually through the use of CARTO, but also through internal. So I think the adoption overall is pretty good. But we got some great news today. So the first one is that Snowflake, we're announcing a native support for H3. So it was possible to use it before, together with the CARTO Analytics Toolbox, but now it has natively added to the platform. So you can actually, the performance is better, it's maintained by the data warehouse. That's actually going to be like great news for anybody that is doing a spatial analysis on Snowflake. So these are some of the functions that they've made available. It actually represents them as 64 bits integers, and it has, in some cases, we've seen up to 3 times performance boost from just the regular H3 support that we had. So that's amazing, and I just cannot thank enough. There's a talk about Snowflake later. We'll talk more about it. So that's great. We also have great news that actually we are also breaking the news that Amazon Redshift is also adding H3 support into a product. So if you're like on the AWS ecosystem, now also it's coming. It's in private beta now. Talk to us on the AWS team. They have a booth too. But this is also a very big news for them. And again, 3x performance improvements in some cases. Just really, really good. We also have news actually that came from September, but Postgres had always had H3 support through the H3PG extension, but now actually that extension is made available on PostgreSQL on Amazon RDS. So if you're on that ecosystem, that's also something great. You have it now available on the cloud. So great news on that. And just so you to get an idea, this is how the ecosystem looks like. A very common operation when it comes to H3 is doing polyfills or converting a polygon into a region. It's a very common kind of like a transformation you have to do. And now the major products actually allow you to do that just in pure, very simple SQL. Slightly different because like the way that they treat arrays and so on. But it's, to me, like looking at this slide versus 2 years ago, it's incredible progress that we've done. And I think it also speaks towards the importance that finally these products are looking at, for geo. So I think that's amazing. Now, because of that, one of the things that we've seen, is many organizations are now looking at adopting H3, either for their overall analysis, to reconsider how they model either their data structures, And we've been, like giving a lot of support to our own customers and people who were working on this field. And we thought, like it would be great to kind of celebrate this with, a new what we call H3 acceleration program, which is a program, to help, like organizations get started, with using H3, kind of like applying advanced techniques. And in some cases, we've seen very useful the possibility to just take one specific use case within the organization and help them to recreate it using H3, to get, like the benefits from scalability and so on. So if you want to apply, this is available as of today too. So that's also great news. Now, the last part, Gen AI. So, I mean, probably you've heard, like Gen AI this year like a million times, but it's actually really, you've seen, one use case when it came, towards, like parsing and, like using it to help you on ETLs and process, so on before. But we find in Gen AI to be a very fundamental kind of shift when it comes to how to design map experiences. So I like to call it, like democratizing the usage of maps with conversational GIS. And for that, we've been working over the summer with Google Cloud on a solution that we call conversational maps. That essentially allows you to talk to your maps. And the idea with it is like, we were talking yesterday about it, like we are all here like mapping experts, right? So we like to see maps, we like to explore on the maps, we like to kind of try to understand them and get, like the insights that they showcase us. But the reality is like there's a lot of people out there that have a real struggle understanding the maps that we produce, or, or extracting all the value and all the insights that we actually have done in there. And this is where Gen AI has a lot of potential of democratizing, of, like of simplifying, of allowing someone that is not so good at reading those maps and kind of like extract the information that they need. And in that way, make, like our work much more powerful. So it is an AI engine, like we're calling it here. And we developed it together with one of our partners, Clear Channel. So Clear Channel has all these billboards in many, many locations. And we've been working with them on their solution called Radar View that allows you to essentially kind of like filter billboards to match a campaign that you want to make. So if you're going to make a campaign around electric cars, like deciding which are the places that will fit better for your use case, right? So that's actually their Radar View solution. And in a very typical kind of like a scenario, and that I'm sure you are familiar, I mean, their application, and you will see a demo in a minute, Kala has a lot of potential. There's more than 70,000 possible filters and operations that you can do in that typical map application, right? Of, from, like selecting a specific kind of like audience segments, like to call like different type of billboards and different type of locations, co-location to specific retailers, etc. So it's a lot of options that, like it's really powerful, but it can be very intimidating, and very often what happens that we see is like a lot of users, unless they're advanced, they wouldn't really use it, or they will use very, very little. So what we've actually come up with then is with the idea, and I have here a video I'm going to be playing here, of this solution, where adding Gen AI simplifies a lot this process. This is Radar View. This is the tool that I was describing. So you see here on the map, typical Kala map, I have all the billboards, and instead of going and filtering, I'm actually asking them, like I would like to run a campaign on electric cars, right? So I'm a vendor, I'm looking, and Gen AI understands, like the intent, understands the filters and the possibilities of the application, and automatically selects them for you, right? So now we filter to, I think, like 10% of the billboards, and now we want to, for example, focus on a specific area. And the Gen AI can also understand the map operations that you can make. So it can zoom in, it can filter down, it can drill down. So essentially it's kind of like manipulating the application like any expert on this application will do, but just understanding the intent from the user. So in this case, I'm focusing only in San Francisco, and it's just kind of like looking at it. And like we also can say like filter billboards that are only close to charging station or to supermarkets or whatever, like mix that. And we've added, you will see with embeddings and so on, the possibility to add all those filters, and and actually Kala will perform an analysis like this, just I think with just with a very, very simple chat. So I think this can be really a game changer if we think about it on the way that we design our map applications. So if you have a map applications that have a lot of powerful capabilities that, has a lot of filters, has a lot of, analysis that you could do. Consider how, Gen AI could really simplify that process for a user, by allowing them just to express what they're trying to get, and then the tool will allow them to just see that. Now, of course, you might wonder, it might be, that the answer is wrong. That's why I think right now, the way that we're looking at this, is very important that the user experience is very visible. So if I'm looking for electric cars and it's selecting certain filters, I need to see which filters have been selected. And if I'm not happy, I have to be able to change it. So it cannot be a black box. You have to think of it, as an assistance to the work that you're doing, right? And by doing that, the user has the confidence that it's helping them, but it has the control, it's understanding what is happening behind the scenes. And that's also very important because that's the way also you're going to improve the Gen AI by actually capturing when it gets it right and when it gets it wrong, and and you can do that to fine tune even better towards your map application. So we think this is going to be a game changer again to change applications that are sometimes only very little used by only a few experts and really opening up to a much bigger audience. Oh, there you go. Yeah, and how is this done? So again, we did this in partnership together with Google. In this case, we're using Palm 2, their model, and we're using it within the context of Vertex AI, which is their AI platform that we use from BigQuery. So it actually means that you can run this type of analytics directly on SQL. In this case, you're going to be putting it on top of your own assistant application, as you can see on the left, and together with CARTO. But it's actually, I'm not going to say it's super easy, but it's definitely accessible. And one thing that it's also very important that we're finding here is the progress that they're going and the speed that they're developing. For example, if you have a lot of categories, a lot of options, you might have to create your own embeddings database to filter, so that you don't have very long prompts and so on. So a lot of those capabilities are already built into these products, and by leveraging them, within the BigQuery or your data warehouse systems, and the same is coming in Snowflake, coming in Redshift, and so on, will actually allow you to build interfaces like this in a very short period of time. So we're pretty impressed by the capabilities that this offers. Well, so here you have it. So again, there's three things: the data cloud and its capabilities now for accessing seamlessly data providers, and and be able to create analytics that react on real time. H3 indexes to unite it all and to have a common geographic support system, and a Gen AI that allows it to be consumed by anybody within within the organization, or that is making it really, really powerful and accessible to use. So I think those three things are going to be a very, very good tenure, and you should really watch out on the months to come. So that's all. Thank you very much.